Welcome back to the session. We'll continue with the networks, different types of topology, star topology, bus topology, ring topology. Okay, next we'll go with the next one, bus topology. The preceding examples all describes point-to-point connections. A bus topology, on the other hand, is a multi-point. One long cable acts as a backbone to link all the devices in a network. Okay, we can observe the figure here. One cable we are going to use, that is an end cable. Here we are going to end this cable. In that middle, by make use of tap, we are going to connect a system. Okay, this system is connect system 1, 2, 3 like that. N number of systems we can connect by make use of an end cable. Okay, this is a looking like a bus, so that we can call it as a bus topology. Okay, with respect to that, we have some advantages based on this bus topology. Bus topology includes easy of installation. It is very easy to install, and backbone cable can be laid along the most efficient path. Then it will be connected to the nodes by dropping the lines of various lengths. A bus uses less cabling than mesh or star topology. The main advantage of using cabling. Here we are going to use less cable when compared to the mesh and star topologies. In a star, for example, 4 network devices in the same room required 4 length of cable reaching all the way to the hub. In a hub, this redundancy is eliminated in the bus topology. The backbone cable stretches through the entire facility. Each drop line has to reach only as far as the nearest point on the backbone. Okay, these are the main advantages of this bus topology. Next, we have come across disadvantages of bus topology are it will be including difficult reconnection and fault isolations. A bus is usually designed to be optimally efficient at installation. It can be difficult to add new devices. Okay, it's very difficult to add the new devices, and the signal reflection at the top taps can cause the degradation in quality. Okay, this is the degradation can be controlled by limiting the number and spacing of devices connected to a given length of a cable. If I'm going to add new devices, may require modification or replacement of the backbone. Okay, these are the main disadvantages of bus topology. Next, coming to the ring topology. In a ring topology, each device has a dedicated point-to-point connection with only the two devices on either side of it. A signal is passed along the ring in one direction. Either it may be in the clockwise direction or it may be in the anti-clockwise direction. We are going to use only one direction. From the device to device until it reaches its destination. Okay, each device in the ring incorporates a repeater. Each system we are going to use with respect to the repeater. When a device receives a signal intended for another device, its repeater regenerates the bits and passes them along with the next. Okay, the concept is here, for example, my cursor is showing this is a source and this is a destination. I need to, sorry, this is a source. If I'm going to share the packet, okay, usually we are going to share the data in the computer in terms of packets we are going to speak. Okay, that is the meaning of packet is data we are going to transmit. For example, here all the systems are connected with the repeaters. Okay, all repeaters are connected, interconnected. Each repeater having a individual system is connected. For example, I need to transmit a data, means data packet from system 1 to system 4 or 5, anything. Now I am going to transmit a data. The data will be entering throughout the network. It will be passed to the every system. It will be passed to the every system, and where the address will be matched, that system will be holds the data, or rest of the system will be drop the packet. That is the main concept. A ring is a relatively easy to install and reconfigure. Each device is linked to only its immediate neighbors, neither physical or logically. To add or delete a device, it will be requires change only to two connections. The only constraints are media and traffic considerations. Here we have a maximum ring length and number of devices. In addition that we are going to isolate, fault isolation will be simplified. Generally in a ring topology, a signal is circulating at all times. If one device does not receive a signal within a specified period, it can issue an alarm. The alarm alerts the network operator to the problem and its location. However, unidirectional traffic can be a disadvantage. In a simple ring, a break in the ring, such as it is a disabled station, it can be disable the entire network. This weakness can be solved by using a dual ring or a switched capable of a closing of the breaks. Okay, ring topology was relevant when IBM PCs introduced its local area network. It will be prevalent when IBM introduces a LAN, that is local area network. A token ring today, the we need for higher speed LANs we are going to use has made its topology less popular. When LANs are come across, the topologies will be going lesser usage. Okay, that is the main drawback of this topologies. Okay, this is about four different topologies. This completes your concept of topology. Next, we'll come to the next topic, that is networks. What exactly the meaning of networks? A ring local area network. The criteria of distinguish one type of a network from another is difficult and sometimes it will be confusing. We use a few criteria such as size, geographical coverage and ownership to make this distinct. After discussing two types of networks, that is LANs and WANs. What exactly the meaning of LAN? Local area network and wide area network. The abbreviation for LAN will be local area network and WAN will be wide area network. We are going to define switching, which is used to connect network to form an internetwork or network of networks. Okay, first we'll discuss about local area network. What exactly the meaning of local area network? A local area network is usually privately owned and connects some host in a single office. For example, you can consider an SVCE. SVCE is a simple office in the central office. What we are going to administrative office, that office you can take it as a consideration. There we are going to consider that, or within a building or within a campus. Anything we can take it as an example for the LAN. Our institute is the best example for the local area network. Okay, we can use single office or building, right wing, left wing, mechanical block, MBA block. We can use, or entire campus we can consider. Depending on the needs of an organization, a LAN can be as simple as two PCs. From two PCs to n number of PCs we can connect in the local area network, and a printer in someone's home office, or it can be extended throughout a company and includes audio, video devices. Each host in a local area network has an identifier, an address that uniquely defines the host in the LAN, local area network. A packet sent by a host to another host carries both the source hosts and the destination host's address. Okay, here we are going to speak about the packets. Why? Because the computer will be share the data in terms of pockets. That is why we are going to call it as a pockets. Okay, this is the basic introduction for the local area network.